All right, so the final section in chapter 3 is called the HL postulate. HL stands for hypotenuse leg. So it says if the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and a leg of another triangle, then the two triangles are congruent to each other. The key, though, is, it says it right here, in order for you to use the HL postulate, you must state that the triangle is a right triangle before you use it. So that is the key. All right, so let's look at, it says number 6 right there. So I'm just going to set up my proof here. So I've got GH congruent to GK, and GJ is an altitude. So there's my given. So I've got GH and GK, and we know GJ is an altitude. Well, that's a vocabulary word, so I'm going to use that. So definition altitude, which tells me I have two right angles. So angle GJH and angle GJK are right angles. Now, in order to use the HL theorem, typically in the past, what we've done is then say the two angles are congruent. But to use the HL theorem, you don't need to use that notion. You just need to state that the two triangles are right triangles, and in order to be right triangles, they need to have a right angle. So, triangle GJH and triangle GJK are right triangles. By definition, right triangle. Now, if you want to say they're congruent first, the angles, and then say they're right triangles, that's fine. Now, the other thing we know is that GJ is congruent to GJ by the reflexive property. So according to what we have, we spell ASS or SSA, which is ass forwards or ass backwards, either one. And we know we don't have that. So that is where the HL postulate comes into play. So we have enough information then to prove the triangles are congruent. So not one of our traditional ways, but we can say that triangle GHJ is congruent to triangle GKJ now by the HL. And you just write HL, that's it. It does the same thing that side angle side or side 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 would have. So I'm just going to come over here because I'm running out of room. So I know Cpctc comes next. And my goal is to prove that GJ bisects angle HGK, which means for my Cpctc, I have to state that those top two angles are congruent to each other. And then once they are congruent, I can use the idea of definition angle bisector to write my proof statement for that. Okay, so again, pause the video, copy this stuff down, but you can see that make sure you're using the vocabulary, you're using the new information that we're working with, and obviously you're going to be using a bunch of old information as well. All right, so I'm going to erase this proof now, and we're going to do the second one. All right, number 8. So right underneath it. So we have statements and we have reasons. So first thing I'm going to copy is what we have. Given. So I know this is congruent to this. I know this is congruent to this. And I'm trying to prove that ACF is isosceles. So I have to prove I've got two sides congruent. All right, so I have perpendicular in there. So what I'm going to do is I'm going to say that angle BDC and GEF are right angles. By definition, perpendicular. Then what I'm going to do is I'm going to say that the triangles are right triangles. BDC and GEF are right triangles. By definition, right triangle. All right, so I've got the angle and I've got the hypotenuse. Now I need a leg. So this is where the bottom two pieces, they share DE in common. So I'm going to say DE is congruent to DE by the reflexive property. Therefore, by subtraction, CD is congruent to FE by subtraction, which now allows me to have ASS basically, which is your HL postulate. So I now can see that the two triangles are congruent, the little ones that is. So triangle BCD is congruent to triangle GFE by HL. By Cpctc, I then know if I have to prove isosceles, I need to get to the sides, but there's no way of getting to the full side, so I'm going with the angles. So angle BCD is congruent to angle GFE by Cpctc. And then if those angles are congruent, I can go all the way to the big triangle and I can go opposite. So I can say that AC is congruent to AF by the converse isosceles triangle theorem. And then once those two sides are congruent, I have my